guys, and welcome to my channel. Today we shall discuss the atomic term symbols with respect to the first D transition series. Now, atomic term symbols are very important when it comes to your regular syllabus in coordination chemistry, but also very important when you're answering any of the competitive examinations. For example, GATE or CSIRNET or MHSET, that is Maharashtra's set, or any eligibility test that you all are giving. Atomic term symbols are extremely important. In today's video, what we will discuss is how do you find out the ground state term symbol and the number of microstates for the first row D transition series, the first series of the D block. And along with that, I will also give you all a small tip, or you can say like a trick, wherein without really solving, you can directly find out the ground state term symbol. Okay, so stick to the video, watch it till the end, and let's begin. The two things that we are going to talk about, we start with microstates. Okay, so there is a formula for microstates which we will discuss later, and we talk about the ground state term symbol. Okay, when we talk about the term symbols, there are two types actually. We have the excited state term symbols and we have the ground state term symbols. But this video I want to keep it a bit low with respect to the time, so I don't want a really long video. So I will just talk about microstates and the ground terms. Okay, now atomic term symbol, how do you represent it? This is the way you represent a atomic term symbol. Okay, MLJ. Fine. So this is the way you have to remember it also, MLJ. Just say it 6 times, MLJ, then you will get the hang of it. Okay. So this is nothing but the representation of an atomic term symbols. Okay. Now what the atomic term symbol is going to be, that will depend on the configuration that is given to you, whether it is a D1 system or a D2 system, D3 and henceforth. Okay. First, what we will do is that we will individually identify the terms which are given to us. Okay, because without having a basic foundation, studying any concept really becomes difficult. Okay, so directly instead of diving into atomic term symbols, we'll just do a basic definition part of it, wherein we will identify what is M, what is L and what is J. So first I will write down what these terms actually mean. Okay, so this is the meaning of all these three terms. Now, all of these three terms, they actually belong to the quantum number. Okay, there are different types of quantum numbers. Quantum numbers, I won't talk much about them because they actually go back into your atomic structure or structure of an atom, this type of chapters. Okay, so you can just brush through them. Okay, and then you will actually have an idea of what exactly a quantum number is. Okay, starting with M. M is nothing but the total spin multiplicity quantum number. Okay, M depends on the number of unpaired electrons which are present in the system. That is in simple terms. Okay, actually the exaggerated meaning of M would be total spin multiplicity quantum number, but in simple terms it depends on the number of unpaired electrons which are present in your system. Fine. Next is L. L is the total orbital angular quantum number. Okay, to find out L, there is a very simple way wherein you have 0, 1, 2, 3, 4, wherein the L is going to be S, P, D, F, G and so on. Okay, so to find out L, there is a technique which we will talk about later when we discuss the configuration, but L is actually your main atomic term symbol, the alphabet which comes over there, S, P, D, F, G and henceforth, and it depends on the number that you get, 0, 1, 2, 3, 4. So this particular table to find out the value of L is very essential. Again, this goes back to the structure of atom chapter. Okay, and last but not the least, we have J, which is the total angular quantum number. J is more about a range which starts from L minus S to L plus S. Okay, J is not one specific number, it is actually a range. Okay, you have different values of J starting from L minus S to L plus S. So J technically depends on your M and L, fine. But for today's video or for the D block, J does not play that much of a great role, or rather I wouldn't be talking about J because my focus will be on finding out the ground state symbol, fine. So for that, with today's video we are going to avoid J, but just so that you all know, it is the total angular quantum number, gives you a range which starts from L minus S to L plus S. Okay, so I hope basic definition is clear. Now what we will do, we will take D1 configuration and understand each of the term in detail so that your concept of atomic term symbol simplifies. Okay, so let's start with the very first configuration I have taken is D1. Okay, now I will give you all a list of steps that you all can follow, fine, so that no matter what question you all are being asked on atomic term symbols, you follow similar steps and you will get the answer. Okay, the first thing that we do is we always find out the value of L. Okay, because I have said L is going to be the alphabet, or it is a very important part in determining your atomic term symbol. Okay, first thing we will do is find the value of L. Okay, so draw your orbitals and fill the orbitals as per the configuration that is given to you all. So I have D1. D1, that means there will be one electron. Okay, now we know that each of these orbitals, they are going to have a particular L value. Okay, ranging from 0, I have plus 1, plus 2, minus 1, minus 2. This is how you label these particular orbitals. Okay, so here we have, suppose just so that you all know, if we have a p orbital, then it is going to be 0, plus 1, minus 1. Okay, fine. So this is how we usually label it using the different sets of quantum numbers. Yeah. Now we know that there is one electron over here in minus 2. So what do we do to find the value of L? We take the number of electrons and multiply it into the label that we are giving to it. Okay, the number that we have used. Okay, so what will be the value over here? Minus 2. So L is actually minus 2. But when we consider the alphabet for L, we do not take the sign into consideration. So if it is minus 2 or if it is plus 2, the value of L is going to be P. Okay, initially you consider when you are calculating for the number of electrons which are present, but when you get a final number for L, there the sign does not play a role. Okay, so whether it is plus 2 or minus 2, it is going to have the atomic term symbol of D. Okay, so atomic term symbol L is done. So what did we start with? M, L. Okay, so L we have got. Now we go back to M. Fine, what did I say? M is given by the formula 2s plus 1. M is your spin multiplicity number, total spin multiplicity number. So it is given by the formula 2s plus 1, wherein s is the number of unpaired electrons, the spin which is present, okay, on that unpaired electron. So this electron over here, the value of s is going to be half. Okay, so m depends on the number of electrons which are present and s is the spin that we have. Fine. So 2 into half plus 1 plus 1, this is going to be 2. So our term symbol is going to be D2. As simple as that. Okay, so that's it. What you have to know. Start with L, get the alphabet. Next you move ahead to M. Okay, see how many unpaired electrons are present, calculate and put that value over here. That's about it. Okay, let's go ahead, move to D2. First we find the value of L, draw the configuration. So we have 2 electrons. Okay, we put these values. Okay, so L will be 1 electron into minus 2 plus 1 electron into minus 1, correct? Here and here. So this will be minus 2, minus 1. So this will be minus 3. So the value of L is minus 3, but we do not consider the negative sign. So L is going to be F. Okay, let's find out M. 2s plus 1. Now over here we have half and half. Yeah, so half plus half will give us 1. So 2 into 1 plus 1. So 2 plus 1, that is going to give us 3. So the atomic term symbol is going to be 3F. Okay, it is as simple as that. Let's move ahead and take the next configuration, which is going to be D3. Okay, so D3, I'm going to have 3 electrons. Okay, let's find out the value of L. So 1 electron into minus 2 plus 1 electron into minus 1 plus 1 electron into 0. So this value is not going to be considered. Minus 2, minus 1 plus 0, minus 3. Okay, so L is again 3. So we will have F. Okay, let's calculate S. Now over S, so we have half, half and half. Okay, so S is actually 3 by 2. So M is 2S plus 1, 2 into 3 by 2 plus 1, that will give us 4. This is going to be 4F. Okay, that's how you calculate. Let's move to the next one. What do we have? See, just follow these two steps. Okay, this will save your time and it will make the concept also easier to you. Okay, so next we move ahead to D3 is done, D4. Okay, so 4 electrons in total. Okay, let's find out the value of L. We have 1 into minus 2 plus 1 into minus 1 plus 1 into 0 plus 1 into 1. Here it is a positive sign, so 1 electron in 1. So minus 2, minus 1 plus 0 plus 1. These are going to cancel out, so L is going to be 2. Okay, so for 2 we have D. Fine. Let's calculate M. We have 2S plus 1. What is S? Half plus half plus half plus half. So S will be 2. 2 into 2 plus 1. That will be 5. Okay, so the configuration for D4, the term symbol is going to be D5. Okay, let's take another one. You can solve it on your own also while you are watching the video. If you will do it before me, then yeah, I guess the video is constructive to you. Okay, now D5 will have total 5 electrons each. Yeah, now if you do not do this part, the multiplication part, actually D5 is very simple, you can directly do it. 0 won't be considered. Okay, minus 1 plus 1 cancelled out. Yeah, minus 2 plus 2. So again, this will also be cancelled out. So you will be left with L having a value of 0. Very simple. So for L equal to 0, the symbol will be S. Okay, now let's calculate M. So I have 2S plus 1. Okay, so half plus half plus half plus half plus half. So that is going to give me 5 by 2 plus 1. So this will be 6. So symbol is going to be 6S. Okay, as simple as that. Now let's move ahead. Now the calculations will play a bit more of an important role because we have more number of electrons. Okay, that is we're dealing with more number of electrons. So let's take D6. Okay, let's find out the value of L. 1, 2, 3, 4, 5, 6. Okay, so now we have 2 electrons into minus 2 plus 1 electron into minus 1 plus 0 plus 1 electron into 1 plus 1 electron into 2. Okay, I hope that is clear. So I have minus 4 minus 1 plus 0 plus 1 plus 2. This is going to cancel. So minus 4 plus 2 will give me 2. So L is going to be 2. That means D. Okay. Now a very important part, when we calculate M, I told you M only depends on the number of unpaired electrons. Okay. Now why it does not depend on paired electrons? Because paired electrons, one electron is going to be plus half, the other electron is going to be minus half. So they themselves cancel them out. Okay, so you do not consider the spin when the electrons are paired because you have plus half and minus half. So the overall spin is going to be cancelled out. Okay, so how many unpaired electrons do we have over here? 4. So half plus half plus half plus half. So 2. S is going to be 2 plus 1. 4 plus 1. 5. So the term symbol is going to be D5. Okay, so similarly you can find it for D7, D8, D9, D10. You all can try it on your own. Now we come to the most important part wherein I'll give you a tip which will help you to solve the problems based on atomic term symbols, perhaps within 30 to 40 seconds. Okay. So we come back and now we are going to discuss the most important thing that I had already mentioned earlier. Okay, before we go to that, another thing that I wanted to tell you all is that the beauty of finding atomic term symbols, the ground state I'm talking, is that Dn and D10 minus n are going to have similar atomic term symbols. Okay, so once you find the symbols from D1 to D5, then the set of atomic term symbols are going to repeat themselves. Okay, like D6 and D4, D3 and D7, they are going to repeat. Okay, so as I said, suppose I take D2, then D10 minus 2, that is D8 is going to be similar. Okay, so that's why you have to know how to find the atomic term symbols initially, and then they are going to repeat themselves. Okay, now we'll come back to the point wherein the tip I wanted to give you all. So this is the electronic configuration: D1, D2, D3, D4, D5, D6, D7, D8, D9 and D10. Okay, you just have to remember one word, that is deeds. Okay, you have to remember one word, that is deeds. So this was told to me by my professor, and that's how I remember the atomic term symbols. Okay, but you know the value of L does not have an alphabet, that is E. Okay, so replace E with an F, but remember the word deeds and replace E with an F. Put those symbols. Okay, so D, F, F, D, S, and as I said, it is going to get repeated again. So again put D, F, F, D, S, and that's about it. These are your ground state atomic term symbols. Okay, so D, F, F, D, S. Again I told you they are going to repeat, so you have D, F, F, D, S. Okay, so now the value of L is clear by just remembering one word, that is deeds. The next thing that we have to talk about is how do you find the value of M. Okay, M, remember for D5 it is going to be 6. Okay, calculate. It's very easy to calculate. M, 2s plus 1. So you have 2, 5 unpaired electrons. So 5 by 2 plus 1. So 5 plus 1 will give us 6. Okay, 6. Then you have to decrease the number. So 6, 5, 4, 3 and 2. That's about it. Once you know this set of atomic term symbols, they are going to repeat on the other set. So 6 again, decrease, 5, 4, 3, 2. And what about D10? D10 is again known to you, no unpaired electrons, so you are going to have 1. Okay, I'll just solve it for D10. D10 configuration is this way, wherein all the electrons are going to get cancelled. So the value of L will be 0. No unpaired electrons, so M will be 2s plus 1. So 2 into 0 plus 1. So we are left with 1. Okay, so by just remembering one word, that is deeds, and you fill it up. So suppose you have to find a ground state term symbol of D7 or D3. If you solve it, you will hardly require a minute. But if you want to do it in this way, then you can just put down this table. Okay, within 30 to 40 seconds, I think your answer should be ready. Okay, so just remember this particular term. And remember for D5, you start with 6. Okay, then decrease on either side. And last D10 is again a very easy configuration. So that will hardly take you 30, maximum 40 seconds to even if you want to solve it like in the actual authentic way. So with that, we complete with the ground state term symbols. Okay, so that was for all the configurations. I told you all the tip also. Now the last thing that is left is how do you find the microstates. Okay, now to find microstates, there is a very easy formula: n factorial upon e factorial into n minus e factorial. So this is the only formula that you have to remember when it comes to microstates. Now let's just know what does N stand for and E. N is the total occupancy of the given orbital. Okay, N is the total occupancy. Now what does total occupancy mean? The number of electrons that you can fill in it. Okay, the maximum number of electrons which you can fill in any orbital. And E is the number of electrons which are actually present. Okay, so N value, if we have to do, N value for D will be 10, as in we can fill in 10 electrons maximum. For F it is going to be 14, for S it is going to be 2, for P it is going to be 6. Okay, so N is the total occupancy, maximum number of electrons that we can put, and E is the number of electrons which are actually present. Okay, so for D1 N will be 10 and E will be 1. For D2 N will be 10 only, E will be 2, and henceforth. Okay, so now let's just find out, perhaps we can take for D2 configuration. So N over here is going to be 10. So 10 factorial upon 2 factorial into 10 minus 2 factorial. Okay, so this will be 10 factorial upon 2 factorial into 8 factorial. Okay, this comes out to be 45 microstates. I think this question had come earlier in one of the exams. I don't exactly remember, but I do know that there was a similar question. Okay, so this is going to be 45 microstates. Suppose we take it for D1. So 10 factorial upon 1 factorial into what is it? 10 minus 1 factorial, so 9 factorial. This comes out to be 10. So the number of microstates which are present is going to be 10. Okay, so this is a very easy formula. Just this formula you have to know whenever you have to find the number of microstates, and of course you have to know what is the meaning of N and what is the meaning of E. Okay, so with that I conclude with this part of atomic term symbols. Of course we have to know what exactly the microstates, how do you get the microstates, as in where do you assign these 45 microstates, for which your excited term symbols are important. So we shall talk about it perhaps in another video. I hope you all understood this particular topic. In case you all did, then do like my video and subscribe to my channel. Thank you so much for watching.